Okay, we learned how to find the prime function, the derivative function of a given x. We have a f of x. I give it the linear quadratic cube square root and the rational, right? 5/x. But not all functions are differentiable. What does that mean? Sometimes it's the when you take the limit, it does not exist, right? That goes back to the earlier chapter that not the limit sometimes it doesn't exist. For example, I give you this f of x equals x minus 5. This is one absolute value function. And if I give you c equals 5, I ask you, can you find the slope of the tangent line there when c equals 5? If you remember, how did we do that? That m equals limit x approaches to c, which is a 5, and then f of 5 plus delta x minus f of 5 over delta x, right? That was the earlier definition at a given point, x equals 5, or c. So that limit, x approach to 5, or it's the same as delta x approach to 0, right? Is that the same thing? Yeah, it doesn't matter which way you write, it's the same thing. And then f of 5 plus delta x absolute value. So that would be 5 plus delta x minus 5, the first absolute value, minus the second one should be 5 minus 5 absolute value, and over delta x. Alright, now this one, when I go delta x approach to 0, 5 minus 5 is 0, so I only have a delta x absolute value. And then this is 0, so minus 0, that is gone. And then over delta x, we are in trouble now. Why? Because when delta x approach to 0 from the positive side, which means delta x is a tiny, tiny, small number, but it's positive. Absolute value of a positive number is itself. Then divided by that, I should get a 1. However, when delta x approaches to 0 from the negative side, in another word, when x approaches to 5 from the negative side, okay? Same thing, these two are the equivalent. Then the x is a tiny, tiny, I shouldn't say tiny, it's a number really close to 0, but it's negative. So when you take the absolute value of a negative number become negative delta x, and then divided by delta x, you get a negative 1. What happened? You found your left limit and the right limit, they're not the same. What does that mean? That means this limit does not exist. So you cannot find the slope of this tangent line. Okay, I can show you by just looking at the graph. The graph looks like this. There's a 5, and then 45-degree, this is the f of the x equals absolute value of x minus 5. Okay? Because if you don't have the absolute value sign, it's going to be just x minus 5, right? But take the absolute value, kind of like flip everything up. So you have this one. When x gets approached to 5 from the left side, I choose this one. So that slope is negative 1. If x approach to 5 from the positive side, then I get the slope is positive 1. Can you find a slope, a tangent line here? Nope. Okay, so this is one example that you can see, it's the limit does not exist. Right? Is this a function continuous? Yes. See, you can move, you can keep your pen on the graph without lifting it. Sorry. Sounds good? Now, this means this function is not differentiable. Not differentiable. Or we cannot any other point, at any other point it is, but only at this point it's not. So the whole function is not a differentiable. Okay, so I'm gonna give you another example. You can see, because I supposed to do a lot of numbers. F of x equals, it's going to be x to 1/5. Okay. C equals 0. Then am, or let's see the limit. We're going to find the limit. Delta x approach to 0. F of 0 plus delta x minus f of 0, right? Because that's c over delta x. Okay. So that should be limit delta x approach to 0, and this should be 0 plus delta x is just the delta x to the 1/5 power minus f of 0 to that power is also 0, and then divided by delta x. So that is limit delta x approach to 0, and this means power of 1, right? Okay, so you know this, a to the m power over a to the n power is going to be a to the m minus n, right? Or if n is greater, you can just write, if n is greater, you can just bring that down, so you get a n minus n. It's the same thing, okay? But in this case, this 1 is greater, so I bring that down. So I get a delta x, and the power should be 1 minus 1/5, so I get a 4/5. Alright, now, I got a problem here. So this is, and then when delta x approach to 0, 0 to the power of a 4/5 is also getting close to 0, so this becomes infinity. But when delta x is approaching to 0 from positive side, because there's a 4 here, so this is going to be like a kind of like a positive 0, so that's a positive infinity. And when x is from negative side, then here's a 4 here, again to the even power, and that will give you the also positive. So this is just the infinity. That means this function is not differentiable. Okay, and if you want to draw the graph at that c equals 0 at that point, it should look like because it has something like a that. So no matter this delta x is approaching to 0 from the right side or left side, you always get the positive infinity slope. So that means this function is not differentiable. Alright, so this is what I want to tell you, that not all functions are differentiable. However, the differentiability implies continuity. If a function is differentiable in an interval or on an interval, that means this function is continuous on that interval. So that means the slope of any tangent line of any point, this, if you have a graph like that, so at any point in this interval, if you draw the tangent line, you find the slope of that tangent line, it exists, which means it's not positive infinity. So you're moving your pen along that without lifting. So differentiability implies to continuity. So that is just one thing I want you to know. All right. So that is all for the whole session here about the derivative. Yeah, I think that's all I need to